Alright guys, so let's go ahead and get started on this lesson here. We're doing lesson 10.7 and it's solve for angle in right triangles here. Now before we get started, I do want to go ahead and just do a little bit of a recap on what we saw on the previous lessons here, and just to look back at the trig functions we started off with. Now we do, whenever what we're working with right now is that we're working with triangles that are right triangles, which means that they are 90-degree angles, and we have learned somewhat how to identify what sides in this case are the hypotenuse, which is usually what's across or the opposite side from the 90 degrees, adjacent and opposite. Now these two sides actually vary depending on what angle you're given. If we're given angle A, the opposite side would be BC. If we would be given angle B, the opposite side would be AC. So it all depends on the angle you're given. And in this case, we also saw that if you're doing sine of a certain angle, it's always going to be the opposite side over the hypotenuse. If we do cosine, that would be adjacent over hypotenuse. And then if we do tangent, that would be opposite over adjacent. And I do want to go ahead and recall the acronym we had learned, which is SOHCAHTOA. So this here would be SO, representing SO. This would be representing CA. And this would represent TOA. And this is just telling us that if it's SO, then it's going to be sine, which equals opposite over hypotenuse. If it's CA, it's cosine equals adjacent over hypotenuse. And if it's TOA, it's going to be tangent equals opposite over adjacent. Now, this here leads us to introduce the opposites of our trig functions here, which are our inverse trig functions. And the inverse trig functions, this purpose of these here is to actually find the angles. The trig functions that we learned before, those are more specifically to find sides of a right triangle. The inverse functions here are to find the angles. So today, in today's lesson, we're finding the angles here. And the only thing different here is that we're using inverse of sine, inverse of cosine, and inverse of tangent. So if you guys go pull up your scientific calculator, and let me go ahead and actually pull up the bigger version of this. You can go, we're going to go ahead and go to functions. And in functions, you're actually seeing the inverse of them. So we started off with sine, cosine, and tangent, which is what we used in the previous lesson. In today's lesson, we'll be using sine inverse, inverse cosine, or inverse tangent. So these are the ones we're working with. Okay? So let me go ahead and go back. And let's go ahead and get started on the first example. So let's go ahead and get started on example 1 here. And this is our example. Now they're asking us to find angle L. So we want to go ahead and find the angle L here. Now I do want to go ahead and first identify what sides we're given depending on our angle. So we are given angle L, which is this one here. We don't know it, so that's our goal to find. The side opposite to that is going to be considered obviously our opposite. And then if you guys notice, the other side that's given would be this one here. Now this side is not opposite to the hypotenuse, which means, or opposite to the right triangle. So then this means that this would be our adjacent side. So adjacent, and it's next to our opposite side. So then in this case, if I'm basing this off our SOHCAHTOA, we have opposite over adjacent, which in this case would be tangent. So then I'm going to go ahead and write that down. We have tangent of, let's say this is x. Let's say this here equals x equals my opposite over adjacent. So opposite, which is 35, and my adjacent is 65. Now, the goal in this case is for us to isolate the x. So I want to go ahead and leave the x. In order for us to leave the x, we need to take the inverse of tangent. So then what this is going to do, once I take the inverse, it's going to look as x equals tangent, and it's going to be the inverse version of it, 35 over 65. And this is what we're using to solve for x. So let me go ahead and bring up my calculator here. And let me just make this wider. So then in this case, I'm already on the function sign. I'm already on function. And so in order for me to solve for x, I'm going to go ahead and start off with tangent. It's already pressed on the tangent, inverse tangent. I'm going to go ahead and go back to main. And since we're doing a fraction here, I'm going to go ahead and click on the A over B button so I can create my fraction. And I'm going to go ahead and put 35 over 65. And if we input that, we get 28.30075. It just keeps on going. And in this case, they would most likely be asking us to probably round to 1 or 2 decimal places. So let's see, if I were to round to 2 decimal places, this would give me x equals about, because it's an approximation, 28.30 if we were to round to 2 decimal places. So then in this case, our answer for x, our angle in this case, would be 28.30 or 28.3. So angle L is approximately 28.30 degrees.